Welcome to the DIY Honda Garage channel. DTC P0966 indicates an issue with the continuously variable transmission (CVT) driven pulley pressure control valve circuit, signaling a low voltage or electrically problem in the system rather than a mechanical failure. This code typically arises from faults in the circuitry associated with the valve, which plays a critical role in modulating the pressure applied to the CVT components, thereby ensuring smooth operation and maintaining optimal performance under various driving conditions. In a 2011 to 2015 Honda Civic, the CVT-driven pulley pressure control valve is situated within the transmission, specifically in the valve body, and connected to the powertrain control module, PCM, which oversees the vehicle's power management systems. Identifying and addressing issues related to this DTC is crucial, as continuous driving under such conditions could lead to further complications or failures in the transmission system. The troubleshooting process must be thorough and systematic, ensuring that each potential cause is evaluated in order to confirm the existence of faults and implement appropriate corrective measures. DTC P0966 points to an electrical circuit issue concerning the CVT-driven pulley pressure control valve. This valve's role is essential in regulating the hydraulic pressure within the CVT for optimal gear transitions and performance. If this valve does not function correctly, it can cause various transmission problems, impacting drivability and efficiency. In the 2011 to 2015 Honda Civic, the valve is incorporated within the transmission assembly and interfaces with the PCM, located near the engine. It's vital to recognize that this error is purely electrical, ruling out mechanical failures in the transmission as a cause of this code. Therefore, proper diagnosis should focus on potential wiring faults, damaged connectors, or issues within the solenoid valve itself. There are several potential causes for DTC P0966, with damaged wiring being the primary suspect. If the wiring harness that connects the solenoid valve to the PCM is frayed, broken, or corroded, it can result in poor electrical connectivity and signal failure. Another cause could be a faulty CVT-driven pulley pressure control solenoid valve. If this component does not operate as intended, it can fail to regulate pressure effectively. Additionally, problems within the PCM itself, such as outdated software or internal faults, can lead to erroneous readings or controls that trigger this DTC. Each of these components plays an integral role in the functioning of the CVT, and diagnosing the exact failure area is crucial for effective repair. The presence of DTC P0966 can manifest through various symptoms, all related to transmission performance. Drivers may notice poor acceleration or erratic shifting as the CVT struggles to adjust to changing conditions without proper pressure modulation. Intermittent power losses may also occur, especially noticeable during heavy acceleration or hill climbing, leading to a frustrating driving experience. Additionally, dashboard warning lights related to transmission malfunctions may illuminate, further indicating that immediate attention is required. These symptoms should not be ignored, as they can lead to more significant transmission issues if left unaddressed. A thorough inspection and prompt corrective actions are essential in preventing further complications. The first step in troubleshooting DTC P0966 is to verify the reported issue. Begin by turning the ignition switch to on or pressing the engine start-stop button to ensure the system is ready for diagnostics. Using a Honda Diagnostic System, HDS, clear any current diagnostic trouble codes, DTCs, to reset the system. After clearing the codes, start the engine and allow it to run for at least 1 second before checking for any pending or confirmed DTCs once again. If DTC P0966 appears, it confirms a persistent issue that needs to be addressed in the subsequent steps. However, if no codes are displayed, it indicates an intermittent failure, suggesting the system is functioning correctly at that moment. In such cases, reviewing any freeze data or onboard snapshots associated with the DTC can help replicate the issue under similar conditions. The next step in addressing DTC P0966 involves testing the functionality of the CVT-driven pulley pressure control solenoid valve. This is crucial because if the solenoid is not functioning properly, it could be the direct cause of the DTC. Begin by ensuring that the ignition switch is in the lock position or the engine is turned off, and prepare the HDS to jump the SCS line. Disconnect the appropriate connectors, particularly the solenoid wire harness, which typically has an 8-pin configuration. With the connections disconnected, check if the solenoid valve responds as expected. If the solenoid does work properly, this indicates that the problem lies elsewhere in the circuit, prompting a move to further diagnostics. However, if the solenoid does not operate correctly, you will need to proceed to the next step to troubleshoot its individual components. In this step of the troubleshooting process for DTC P0966, a thorough check for wire continuity is essential. Start by ensuring that the ignition switch is set to lock or the off position. Prepare to jump the SCS line using the HDS to facilitate testing. Disconnect the necessary connectors, specifically the solenoid wire harness 8P connector and the PCM connector B, which typically has 51 pins. With both connectors disconnected, your focus will be on testing points 1 and 2 for continuity, using the appropriate specifications outlined in the service manual. Test point 1 should be on the solenoid wire harness side, and test point 2 on the PCM side. If continuity is confirmed, it suggests that the DNLS wire is intact and functioning correctly. At this point, if the PCM needs a software update or substitution, that should be performed as the final corrective action to resolve the DTC. The fourth and final step in troubleshooting DTC P0966 involves measuring the resistance of the CVT-driven pulley pressure control solenoid valve. Begin by disconnecting the solenoid wire harness, specifically focusing on the 2P connector associated with the solenoid. Ensure the ignition switch remains in the lock or off state during this procedure. Measure the resistance between the two test points on the solenoid valve, according to the specified range. A resistance between 4.9 and 6.6 ohms indicates that the solenoid valve is functioning correctly and would require a replacement of the solenoid wire harness if issues persist. Conversely, if the resistance falls outside this range, it confirms the solenoid valve is faulty, necessitating its replacement. Proper assessment in this phase is crucial as it directly impacts the corrective measures to restore proper transmission function. Final repair verification for DTC P0966 is a crucial step to ensure all issues have been addressed effectively. After all repairs and necessary replacements have been completed, it is essential to conduct diagnostic checks with the HDS. This process involves scanning for any lingering DTCs that may still be present in the system. Once any remaining codes are cleared, start the engine again and allow the vehicle to run for a period to observe if the P0966 code reappears. If everything operates smoothly, without any faults, and the DTC does not return, you can confidently conclude that the repairs were successful and that the electrical circuit issues surrounding the solenoid valve have been rectified. This concludes the troubleshooting process and ensures that the vehicle's transmission functions optimally. Preventive maintenance plays a pivotal role in avoiding recurrence of DTC P0966 by ensuring the longevity and reliability of the CVT system. Regular inspections of the wiring harnesses connected to the solenoid valve can identify any fraying, corrosion, or damage before they lead to significant failures. It's also advisable to keep the vehicle's software updated through the PCM to prevent operational issues related to erratic signals or control failures. By proactively checking the connections at various intervals and ensuring that all components are functioning within their specified ranges, you can mitigate the risks of electrical connectivity issues. This preventive approach not only prolongs the life of the transmission system, but also enhances overall vehicle performance and drivability. In summary, DTC P0966 indicates a specific electrical circuit problem related to the CVT-driven pulley pressure control valve, highlighting the importance of systematic diagnostics in identifying the root cause. The troubleshooting steps outlined provide a thorough method of isolating the issue, whether it lies in the solenoid valve, wiring, or PCM. Proper repair verification ensures that the solution is effective and will prevent future occurrences of this DTC. It's essential to maintain ongoing assessments of the vehicle's electrical systems and to perform regular preventive maintenance to safeguard against potential failures. By emphasizing these practices, vehicle owners can ensure that their 2011 to 2015 Honda Civic operates efficiently and reliably for miles to come. Please like and subscribe to the channel. See you next time.